Hello, my name is Piotrowicz. I'm from Wroclaw University Library. Our library is one of the biggest academic libraries in Poland. We have about 2.4 millions of volumes, and in that number, 500,000 millions of special collections, items, manuscripts, old print books, incunabula, maps, graphic collection, music collection, very, very rich. We are a member of some library organization and our library has participated in many research projects, but what is important when we speak in context of that conference, it is that we have a long-standing experience in digitization of printed items, as well as processing and then presentation of digital objects. We started the digitization processes of own physical resources in 2000. Then we have initiated our digital library in 2005, and the object of that digital library represented in Europeana and in this year we also started and initiated the university repository. The Wrocław University Library has at its disposal experienced staff and technological base that enable us to cooperate in the framework of Impact Center of Competence in Digitization. We were invited to participate in the Succeed project as contractor, and in order to improve digitization workflow in our digital library, it's required to implement tools that can help to speed up and optimize processes. So we tested in the framework of that project two tools. First one, it's Scan Tailor software. It's post-processing tool for scanned pages. It performs operations such as page splitting, skewing, adding, removing borders, etc. It was used for raw scans and enabled to receive pages ready to be printed or assembled into a PDF or déjà vu files. The second one was Tesseract OCR software, open source OCR engine that combined with the Leptonica image processing library can read a wide variety of formats and convert them to text in over 60 languages. Both tools were tested while preparing presentation versions of chosen 12 old printed books from our collection from 16th to 18th century. All only in the single column text layout, printed in different languages, for instance, Latin, Italian, German, Romance, and with different font types, for example, Gothic Roman. The aim of test intended was working out the technological line and workflow for digitization, processing, and presentation of good quality delivery files for our digital library. For the evaluation, the ground truth in plain text format was used, 5 pages from each marked out document. The evaluation was performed by comparing OCR with ground truth and measuring character error rate, measuring word error rate, and comparing OCR from different engines. The research process was realized on server in three following steps. First one, the execution of Scan Tailor program with the font adjustments. After the processing had been done by Scan Tailor program, the visual control and manual correction of wrongly processed files had to be carried out by the operator. It turned out that Scan Tailor cannot precisely read and find the text area. Owing to that operation, it was possible to improve the parameters of the later processing to the satisfying level because we wanted to receive the best quality of poster-master files for the future processing by OCR-C program. Second step, it was saving manual corrections on the server. On server were saved only these files that had to be corrected manually by the operator. The rest of the results of scan-tailor automation operations remained without changes, and for supporting the realization of a second step, the dedicated website on server was applied. In this moment, I would like to emphasize that we integrated two verification processes in one, so the correction of scan-tailor pages and also the verification of completeness and digitization quality in one, and for this reason we optimize the time. Third step, it was execution of Tesseract program. Earlier, the appropriate dictionaries were chosen. We used only the dictionaries which are available with Tesseract software. No additional training tools were applied. And it turned out that small size of fonts were the great problems for Tesseract. Additionally, it doesn't have the tools that enable to point out with precision the text layout and to separate it from the area of graphics. The lack of such a function results in the attempts to apply the text recognition functions from graphical objects like frames, fluratura, seals, etc. As the implementation of new solutions consisting in the integration of dispersed digitization processes and data processing can significantly decrease the cost and increase the efficiency of digital resources creation in our digital library, we carried out this test on scan-tailor and Tesseract programs, and they are of great importance for preparing and organizing technological line for data processing in cloud. In the case of scan-tailor program, it is possible to carry out automatically and efficiently the following tasks: splitting master files into the single pages, turning split pages in order to level the text, removing of mergings and rejections of artifacts, generating of files to be prepared for OCR process. The only problem is an appropriate recognition of the text area. That problem causes that the task cannot be solved automatically. That imperfection doesn't disparage scan-tailor program. It will be tested and applied in our library. The Tesseract program seems to be a very promising tool, and with absolute certainty can be said that the trials will be done to implement it for supporting digitization processes of selected types of library materials. It is essential, however, to refine and improve the quality of documents layout analysis, as well as to the recognition of graphical elements at small fonts. It is interesting that we notice that very interesting files, HOCR, and such a file contains the following data: the recognized text, its location relative to the original image, as well as style. These data are saved by means of XML in form of HTML or XHTML file. When we speak about archiving process, the HOCR files seem to be good form of file saving. Each HOCR file is assigned to specific graphic file, and in this way the adjustment of particular pages of document is possible. And thus the organization of the adjustment process can be more flexible. Additional, I would like to say that after the finishing project, we were carrying out the other project connected with processing of 19th century newspaper printed in Gothic fonts, and we observed very satisfying OCR results received by means of Tesseract used on the object processed to 1-bit version, black-white. Earlier we used color images because in our digital library we used such color images. and I can present it if it's possible. And we also repeated the recognition of a sample of the object with catalog number 319708. It was one for which we have the best results in our tests, but now we have received better. The results now are at the level character error rate 7.80% and word error rate 19.67% versus Tesseract results from our final report. The best one, as I said, character error rate 20.58% and word error rate at the level of 35 and 56%. So it turned out that the creation of good black-white image is an essential element which very positively influences on the OCR's results. If possible, I can try to present this object from our digital library, but I'm not sure if it's really. It's a pastoral, Schlesische Pastoralblatt, and it is this object. If somebody is interested, we have our library website in 3 languages, fully accessible in 3 languages, Polish, English, and German, and digital library in 5 languages. You can connect and see the results or read more about our library. Thanks for your attention.
Thank you for your presentation, useful input again.